Let's get right to working some stoichiometry problems. I'm going to walk you through the general process, and then we're going to work two of the more difficult problems that you have in your handouts, and these will be pretty inclusive of what you may see on a quiz. Okay, so let's go over the basic format for looking at two different substances in a stoichiometry problem. So you're going to be given a substance, and it may be in grams, it may be in moles already, it could be in liters, it could be in molecules, but your first goal is to take that given, whatever the substance is, whatever the unit is, and get it to moles. So you're going to have to do a mole conversion first. Sometimes you'll be given a substance in moles, and so you can skip that first conversion. The next step is to compare the mole ratio of what you're given versus what you want. So in order to get a mole ratio, you're going to have to look at the coefficients. So if you have a problem, let's just say where you have H2O and O2 combining to form H2O, okay? If I were looking at hydrogen as my given, I would look at the coefficient in front of hydrogen, and the coefficient is equal to the number of moles for that substance. So if I were comparing, say, oxygen gas and hydrogen gas, my wanted would be 1 mole of oxygen gas, again, just looking at that coefficient spot, over 2 moles of hydrogen gas. And this does a couple things for us. It tells us that oxygen gas and hydrogen gas are in a 1:2 ratio, and it also allows me to cancel out the moles of my given in order to get to the moles of what I want. So your mole ratio is the new step here. We've done mole conversions to grams to molecules. The mole ratio is what makes this stoichiometry. So now you have your substance that you want to find in moles. If your problem asks you in moles how much you need to have, then you're done. However, a lot of problems ask us to convert that to grams because you will be actually doing an equation. So if you have a certain amount of grams of hydrogen gas or liters of hydrogen gas, whatever, how many liters do you react with the oxygen as well, so you know how much to make. So you'd have to go ahead and then convert it to grams or liters or whatever your wanted unit is using your mole map. Okay, so in this particular problem, we're already given our equation, and it looks to me like it's already balanced. The question asks us how many grams of sulfur are needed to react with 10.0 grams of copper. So I'm going to go ahead and underline my 10.0 grams of copper. That's what I'm starting with. And I'm going to write that in the upper left-hand corner of my T-chart like I always do. And then I'm going to figure out what are they asking me to find. So I'm going to circle my wanted. They want me to find grams of sulfur. So before I even approach that, I know the very first step in a stoichiometry problem is to go ahead and convert those grams to moles. They have to be in moles in order to compare one substance to another substance. So the mole conversion is 1 mole of copper is equal to the molar mass of copper. Looking on the periodic table, the molar mass of copper is 63.55 grams, and I want to make sure that I'm using 4 significant figures for that. So grams are going to cancel, and now I'm in moles. Now that I have my given in moles, I can go ahead and use my mole ratio. So I'm going to look at my equation to see what the coefficients are, because the coefficients are equal to the number of moles. So for copper by itself, which is what I'm given, I have 2 as my coefficient, so therefore I have 2 moles of copper. This is where we start to switch over from the moles of what we're given to the moles of what we have. So 2 moles of copper, I'm looking for grams of sulfur, so I want sulfur by itself. Looking up here, there is no number in the coefficient spot, so I know that that is 1 mole of sulfur. So all we're saying in this step is that 2 moles of copper are equivalent to, they're in a 1:2 ratio, copper and sulfur are. So I'm going to look at my units. I now have moles of sulfur. The question doesn't ask me for moles of sulfur, it asks me for grams. So I'm going to have to extend my line one more time and convert my moles of sulfur to grams of sulfur. I know that 1 mole of sulfur is equivalent to the molar mass in grams of sulfur. which is 32.07 grams of sulfur. Canceling my units, I now have grams of sulfur, which is exactly what my question asked. So I'm going to go ahead and calculate this. I'm going to multiply 10.0 times 1 times 1 times 32.07 to get 320.7, and I'm going to divide that by the bottom. 63.55 times 2 times 1 is 127.1. When you do this, you get 2.523 grams of sulfur, and I need to double check my sig figs. My given has 3 sig figs, therefore my answer must as well. So 1, 2, 3. 3 tells the 2 to stay where it is, so my final answer is 2.52 grams of sulfur. This is probably the hardest type of problem that you're going to see, and it's one that doesn't give you the equation. So you're going to have to use your naming and formula writing rules, your balancing rules. Sometimes you may have to even predict the products. This one tells us what the products are. So we're going to go ahead and start by creating our equation. All right, so iron 3 oxide tells us that we have an iron with a +3 charge. Oxygen has a -2, so let's make that a neutral compound by dropping and swapping. 2 comes to iron. 3 goes to oxygen. I'm going to erase my charges. Reacts with, fancy way to say plus, carbon all by itself. It is not a diatomic, so I'm not going to put a 2 after it, to give iron, and as a plus, carbon monoxide. So this is my basic equation. Do not forget to balance your equation, or your mole ratio is not going to come out right. So when I balance this, I have 2 irons here, so I'm going to put a 2 in the coefficient spot. And I have 3 oxygens on my reactant side, so I'm going to put a 3 in the coefficient spot. I now have 3 carbons as well, so I'll put a 3 in the coefficient spot with the carbon in the reactant side. Okay, so now we have a balanced equation. Let's go ahead and approach this problem and see what they're giving us and see what they're asking us for. So how many grams of iron 3 oxide must react to produce 112 grams of carbon monoxide? So there is my given, and that is 112 grams of carbon monoxide. They want me to find how many grams of iron 3 oxide have to react to get that final amount. So that will be my wanted. So here I'm going to start my T-chart, and I can't work with grams. So I'm going to convert my grams to moles by using the molar mass of carbon monoxide. So 1 mole of carbon monoxide is equivalent to the molar mass, which is 1 carbon plus 1 oxygen, which is 28.01 grams of carbon monoxide. All right, so let's get rid of our grams. We're now in moles. Now that I have moles of my given, I can convert that to moles of my wanted by looking at the mole ratio. I want to get rid of moles of carbon monoxide, so I'm going to put that on the bottom, and they're asking me to find the moles of iron 2, or iron 3 oxide, excuse me, not fluorine. Okay, so I need to go back up to my balanced equation, and I need to look at the coefficients. I have 3 in the coefficient spot for carbon monoxide, so that's my mole ratio. And looking at iron 2 chloride, it is just a 1. So there's my mole ratio. I've gotten rid of my moles of carbon monoxide. I now have moles of iron 3 oxide. They didn't ask me for moles of iron 3 oxide, though. They asked me for grams. So last step is to convert those moles to grams. And I know that 1 mole of iron 3 oxide is equivalent to the molar mass of iron 3 oxide. So to save us some time, I'm just going to tell you the mass is 159.7 grams for iron 2, or iron 3 oxide. I keep saying iron 2, I'm sorry. All right, so we've gotten rid of moles. We are now in grams. That is what the question asked me for. I can start to finally calculate this. So multiplying across the top, 112 times 1 times 1 times 159.7 gives us 17,886.4. Multiplying across the bottom gives us 84.03. Divide top by bottom, and you get 212.857. And I need to go back and check how many sig figs are in my given. I have 3 sig figs, so 1, 2, 3, draw the line. The 8 tells us to round up. My final answer is 213 grams of iron 3 oxide are needed to react to produce 112 grams of carbon monoxide.